I haven't seen these slides, so I'm just going with the flow, guys. Whatever I got to talk in the beginning.
Sounds good. Well, welcome everyone to the RITIS workshop on understanding origin destination data. It is a beautiful Friday morning here in the Mid-Atlantic, so I hope everyone is enjoying the sunlight. For now, just a quick couple of housekeeping items. This is Zoom webinar. If you're having audio issues, you probably can't hear me right now, but hopefully you can rectify that using some of the information on this screen. This webinar is being recorded, and if you have any technical issues, feel free to email Esther at ecleat@kmjinc.com. We will not be using the chat box today. We are using the Q&A box. The Q&A box helps us keep some of your questions threaded and answered accurately and precisely. So down on the bottom of your screen, you can see the QA toggle. If you have questions, please, or comments, please write them in there. And we're going to monitor that during the webinar, and we'll be able to keep track of everything. For now, it is my pleasure to turn this over to Denise Marco, the TSMO coordinator of the Eastern Transportation Coalition. Good morning, Denise.
Thanks, Justin. Can you hear me okay?
We can hear you.
All right. Good morning. I see that as we're continually having people are still entering, I'm going to slow this down a little bit. I'll tell you a little bit about who we are and why the Eastern Transportation Coalition is part of this workshop. Again, we're basically a partnership of, it says 17 states, but it looks like, and the DC, we've just had Kentucky as a new member. But basically, for those of you that are not aware of the TETC, basically we focus on connecting public agencies across modes of travel, and we have a very big data tool program. RITIS is a core component of it. Again, as the screen says, in the past 25 years, we've evolved. We've come from a small highway focused group. We've got now more than 200 public agencies that really work, and many of them work in the RITIS platform, work in the TDM marketplace, and the stuff that we're going to talk about today. Even though we have 3 core programs, TSMO, Freight, and Innovation, RITIS falls under the TSMO program management, and so this is who we are. Next slide, please, Justin. Alrighty, so again, as I mentioned, and this is part of every workshop and presentation we do, as of March 1st, we just added our newest member, which is the Kentucky Transportation Cabinet. If anybody's on the call, we welcome you, and we're looking forward to many more years of collaborative work. So they are, so our new logo on the right, which is still needs to be updated, will have Kentucky in it as soon as we get it done. Alrighty, next slide. We've got 337 registered. This is a huge turnout for this type of a workshop where we're excited. We've got 29 states. We kind of bucket them, as you can see down below. So we've got some turnpike authorities and DOTs, MPOs, federal agencies, folks from the universities, vendors, and consultants are all part of this program today. And so we welcome you all from whatever venue you're at. Okay, next slide. We do this typically as well as part of a standard slide to tell you a little bit about the coalition. The calendar link is in the box to the right there. These are some of the upcoming events. Esther has also put that link in the box for you. So we bucket this and change this into a recent and upcoming. So in the past, since the past 6 months or so, we have a transportation data marketplace. We are very close to finalizing a contract that will allow all of our member states, to buy data sets, to buy probe data, volume data, freight data, waypoint data, OD data through the marketplace at a discount. So that's part of the marketplace and vendor meetings, state and vendor meetings that we've been going through for the past 6 months. We are almost done. April 13th, next Wednesday, should be our last meeting, and we'll be good to go to start writing task orders for those. HOGS groups, those are our highway operations groups. We have several in the area. We've got 5 of them in the region. We've been working with the New England group quite a bit this past winter, dealing with snow and ice operations, how they're capturing performance index data, things like that. So that's kind of our highway operations groups. You'll see one that we recently had. We're focused on freight in February. We just had one yesterday dealing with road and weather information systems in winter operations. We have a traveler information program. We held a summit on March 17th, really focusing on trucking navigation. So we have a steering committee. We have some working groups that deal with Waze. We have a direct link with the Waze engineering and product teams that we work with them on helping to improve their app. And then we do a lot of work, as you can see, with RITIS. The workshop we had in March 29th dealt with performance summary reporting. Some of you may have been on that. We also have our an enhancement working group that talks about and looks at funding and how we can improve some of the existing functionality of RITIS, as well as improving and adding new functionality. And then down below, what we have coming up, as you can tell, we've got an electric vehicle workshop. We've got some strategic planning that we work on, develop our work plan for next year. And then a freight committee. We have a very active freight data committee. So again, a little bit about the coalition and about all the work that we do. You're here in the data program right now with the RITIS OD workshop. Next slide, please. So these are today's speakers. Rick Ayers is our public sector advocate from the CATT Lab. And then we also have Matt Glasser, who is the assistant state traffic engineer, who will be there for a little while longer, Matt. I think I'm thinking maybe to the end of April. He is then moving to the private sector, but he will still be involved in this in some manner, shape, or form. So again, I will I'm going to turn this over to you guys. I can't find the bios. Sorry, guys, but you guys are very active and very enthusiastic about this. So I'm just going to get right to it. Let me have the next slide, please. All right, Matt, go ahead. I'm going to turn this over to you to set the stage and to tell us all about this. Okay.
Well, I appreciate it. Can you hear me, Denise?
I can.
Excellent. Well, thank you so much. Appreciate it, everyone. I'll be very quick. I just want to say welcome and thank you everyone for attending this morning. Georgia did something similar to this a few months ago. And again, thank you to Rick Ayers and the CATT Lab for hosting us down in Georgia. That was a great success down there. We had some really great feedback from the folks that attended, certainly to help tweak this presentation just a slight bit, but also, coming out of that, we got great feedback from the team of just saying, this really helped us understand what all was available to us, what's coming up. I know that a few folks from Georgia have shared reports with Greg and Rick and said, hey, here's how I'm looking at this. And, am I looking at this correctly from an operations perspective, from a planning perspective, from a project development perspective? So I know that they got a lot out of it. And I know that Rick and Greg have done an excellent job in framing this and making sure that it's something that really is going to make sense for the folks that are using these tools on a day-to-day basis. So with that, I think I get to be done. Rick, you get to talk for the next 1 hour and 52 minutes.
Fabulous. Thank you, Matt, for setting the stage, and to the Eastern Transportation Coalition for the opportunity to share with everyone that's on the line today. It looks like we've got about 150 people already that are participating in today's workshop. Happy Friday, everyone. Again, my name is Rick Ayers. I am the public sector advocate for the CATT Lab, and amongst the many roles in which that I serve the CATT Lab, this is one of them, to provide insights and deliver professional development, content and information with regard to some of the innovations that the CATT Lab is responsible for deploying to state agencies like many of you that are on the line today. We have partnered again today with the Eastern Transportation Coalition. I think the timing's really nice, and that what Denise had shared a moment ago about the transportation data marketplace again aligns with the content that we're going to share today. And that is, we're going to focus on this technology out of the CATT Lab, part of the RITIS platform called Trip Analytics, and how it's leveraged to bring trip and travel pattern insights from OD as well as waypoint data across your region and network. In terms of agenda for the day, we've got a lot to cover, and as Matt indicated, in the next hour plus that we have together, I am going to spend a little bit of time kind of setting the stage, provide some background to how we got to where we are today with regard to trip analytics from an organizational perspective, the CATT Lab, and how we got to deploying this super cool technology. I'll give you a little background about the data that I will be using is largely for the video demos that I've integrated in today's presentation. And a lot of the use cases I'll share with you. We'll talk about that data a little bit, provide some context there. And then I'm going to review the current release of Trip Analytics. Today we've had Trip Analytics in a deployed state for several years now. It's version 3.0. I'll be excited to kind of touch on and share with you a little bit about our next release, the next generation of Trip Analytics as well. I'll cover some use cases that several state agencies have implemented as a result of having these super cool tools at their disposal for performing various sorts of trip and travel pattern analysis. And then I've set up with some support from my colleagues, Michael and Greg Jordan, I've provided some scenario-based use cases that really explore a couple, 2 or 3 different options for how you might want to think about leveraging the technology. They're not applied use cases, but some really interesting examples of how the technology can be leveraged to support work in your respective agency. We're going to have a series of polling questions throughout today's seminar to support a number of things. One is we want to gauge your awareness, perhaps first and foremost, with regard to this sort of technology that I'm going to share with you today, the type of data that we're going to talk about and leverage, try to pull out from you also what you might need from technologies and data like this. So our first polling question for the day, I'm going to set up the polling question, and then my friend Esther is going to put up the actual poll for you to answer. But would love your feedback for this first polling question, which is, are you a current user of RITIS Trip Analytics from the CATT Lab? Yes, no, or we give you an option, no, but my agency is interested in exploring trip analytics and related waypoint origin destination analytics solutions. So if you would take a moment, answer that question. This would be great feedback to kind of gauge what, how many of you are actually using the technology, or perhaps how many of you might be interested in technology like what I'll be sharing with you. And Esther, the results for this first poll are?
We're going to give people about 10 more seconds. It looks like people are still answering.
Okie dokie. Thank you. Polling question 1. A lot of you that are on the line today may have actually seen me present, and we're in the class down in Georgia. I had a big group that Matt had organized down there, about 90 folks. So if some of you are with me again today, it's good to have you back. You're certainly familiar with Trip Analytics, but for those of you who are not, we got a fun day ahead of you, or a fun morning ahead of you. All right, what's our results? All right, so about 25% of attendees are using, 38% have not used it, but a good percentage of you are interested in using tools like this to explore how to work with OD and waypoint data. Thank you, Esther, for setting that up. So just want to give everyone that's on the line a little background to how we got to where we are today, and what's driving the evolution of Trip Analytics, this solution for exploring OD and waypoint data. The CATT Lab's been around for about 20 years. We are a software organization that's completely focused on you, agencies like yourselves who have needs to understand and analyze transportation data. Historically, you're probably familiar with RITIS as a suite of tools to support and analyze understanding probe-based data. But more and more, we've got customers throughout the country and abroad that saying, hey, you know what, we'd really like to understand and dig in to understanding trip and travel patterns around our region and our state. So as customers demand, interest, and need for a certain product, analytic and data visualization products, we respond naturally. You know, one of the other things is that's been the kind of the architecture and development driver for trip analytics is that in today's marketplace for these sorts of tools that you're going to see, they're largely they're commercial-based products are largely specific to the data and the platform that kind of packages that data. We have built out trip analytics to be data agnostic. It's kind of an industry exclusive capability that the CATT Lab provides through trip analytics. You're going to see a lot of examples today of waypoint-based data from our friends from INRIX, but our tools, this technology is built out and architected to be data agnostic. We do have quite a few agencies and users across the country that also needed, hey, you know what? I think I know what's going on from a movement perspective in my region. I need some tools to help validate that. So if you're a modeler, you're doing some planning activities, these tools have been built out to support validation, but they're also built out to help calibrate modeling activities within your community, within your region or state. So on that front, we do have a couple of modeling-based questions that we want to push to you and see if you are actually, what sort of modeling work, if that's something that you do. This will help inform us and how we move forward with trip analytics. Is first question, do you use macro level regional demand models as part of your job function? Yes or no? Now, some of you may be leveraging these sorts of capabilities. We want to know about it, hear about it. This insight, the feedback that you provide us, gives us an opportunity to follow up specifically with you and kind of dive into how you're using these macro level regional demand models. How we doing, Esther?
We're going to give people about 10 more seconds and then we'll end the poll and share the results.
Fabulous. Do you use macro level regional demand models as part of your job function? Yes or no? Okay. Our results.
All right, we're going to close the poll in 3, 2, 1.
I love this instant feedback. Very cool. So about 50% of you are using macro level regional demand models as part of your work. So this should be what we share with you, what I share with you today should be pretty interesting and insightful. Sort of part two to this, maybe the same sorts of feedback. Do you use micro simulation models as part of your job function? Yes or no? Bang that out. Let us know. I'm not a modeler, but I know that both of these questions are relevant to our product management team, the developers who work hard behind the scenes to make the tools and capabilities and visualizations that I'm going to share with you today possible. And you know, we at the CATT Lab really, again, like to focus on user demand, need, and functional and interest in specific functional requirements. So this helps us out a lot. So thank you. And our results. Yeah, about the same. Awesome. Well, thank you for providing a little bit of feedback on that front. We appreciate it. Today's workshop would not be possible without our partnership with the Eastern Transportation Coalition. So to Esther and Denise in particular, and Justin, thank you for making this happen. Thank you for working with us. But the timing is particularly interesting in that the Eastern Transportation Coalition is about to finalize, as Denise mentioned, their transportation data marketplace, the TDM for short. Amongst the transportation data sets that are available through this marketplace that you're certainly welcome to head to the Eastern Transportation Coalition's website to explore more detail, is several OD and waypoint-based data sets from a variety of providers. And so this idea that, wow, we as state agencies have an opportunity to kind of tap into this transportation data marketplace and pull in relevant data to help us kind of answer analytics questions about origin destination or freight movement and leverage waypoint data. Really cool that, oh, wow, RITIS or CATT Lab's got some tools to help analyze that. Now, what we also like to hear is what data sets are you exploring and wish the CATT Lab to integrate into Trip Analytics? Well, you haven't seen what Trip Analytics is capable of. We do know that there are some standard market industry data providers, as you just saw in that previous slide, that provide OD or waypoint-based trip travel pattern-based data. So we'd like to hear from you. Which of these providers are you interested, maybe working with already? Select all that apply. Are you using AirSage, Future Mobility Labs? How about GeoTap, INRIX? Much of what you'll see today will be based off INRIX waypoint data, trajectory data, the National Household Transportation Study or Survey, Streetlight, WeJo, and others. So if there's some other OD or waypoint data that you'd like the CATT Lab to consider integrating into Trip Analytics, again, it's an open data platform. Just put in the QA box, hey, Q2, the waypoint OD data that I'm interested in is blah, blah, blah. All right, so Esther's put up the polling question again. Select all that apply. This is really helping to feed our understanding of which vendors you're actually exploring and evaluating in terms of their data, or maybe you've already had their data on hand for several months, but it's been difficult to kind of explore and analyze that data. Guess what? Trip Analytics could be a really, really nice solution, but we'd like to hear from you. How's the feedback coming with that poll, Esther?
All right, we're going to close the poll now and share the results.
Fabulous, thank you. Okay. So you got 20% AirSage, 10% Future Mobility Labs, almost around 15% for GeoTab, INRIX, 73%, NHTS. Okay, so some of you would be interested in taking a look at a quick demo I have later today. Streetlight, 62%, and WeJo. Interesting, we've done some integration work already with some test data from WeJo. So that's nice to hear that some of you are exploring WeJo as well. And a few of you indicated some other data sources. We organize the way we think about architecting a solution out of the CATT Lab based on use cases. What's the functional use case? We generally categorize much of what we do, not only within like probe data analytics and some of the other tools that we design and develop out of the CATT Lab, but even with Trip Analytics, we like to think about you, the user, what are your operational and or planning based use cases? And what's fed us from a design perspective are these sorts of scenarios. And again, I've got a couple of more use cases. I want to set the stage, helping us to kind of hone in future design and development activities for this product. So help us out, let us know. This might take a little bit longer for folks to review and read, Esther, so thank you. But setting the stage again, which of the following operational use cases applies to you and how you support your agency? Okay, these are operational: planning detours or reacting to emergencies, assess traffic impacts from a pandemic or related natural event, planning for maintenance of traffic through planned work zones, before and after studies, evaluating impacts of signal retimings, evaluating detour routes, evaluating evacuations, or the impacts of road closures, crashes, responding to public and or elected officials in support of inquiries regarding congestion and or trucks cutting through the neighborhood, and maybe an alternative operational use case. Select all that apply. Again, from an operational perspective, we'd love to hear about how you may apply this sort of analytics capabilities to support your organization. How's things looking, Esther?
We're going to give people a few more seconds to answer, and then we'll close the poll.
Fabulous. We got one more polling question after this, and we'll jump into the content. All of this is setting the stage, of course, for building out and expanding much of what you're going to see today in Trip Analytics. So we appreciate your feedback. This, again, drives design and the product team to evolving the solution to support your needs and your interests. So thank you. All right, Esther, what our results look like. Nice feedback. Thank you, everyone, for that. We will note that, review it in more detail with the product management team. We're going to extend this similar sorts of questions on the planning side. So which of the following planning use cases may apply to you and how you support your agency? Evaluate the impacts of tolling. Maybe you're doing some travel demand model calibration or travel time reliability studies. Once again, maybe you're responding to public and or elected officials in support of inquiries. Select link analysis. Maybe you're identifying freight hotspots or doing needs assessments, tolling assessments, assessing demand for inter or intra-city transit and or park and ride lots. And again, a other option, make sure you put in Q6 as part of your Q&A response for other scenarios that you might be working with, that tools from an OD and waypoint perspective could help you in the work that you do. So I'll give you a few more moments to respond to that. And then we'll jump into the crux of today's presentation.
All right, we're going to close the poll in 3, 2, 1.
Nice. Large number of you, travel time reliability studies. Everybody's got to respond to the public, right? The phone calls, quit it with the phone calls. All right, again, thank you everyone for humoring us, but you, all 160 of you, with the exception of those who's driving and supporting today's presentation, you have essentially contributed to some fundamental design elements as we evolve Trip Analytics. So RITIS, as you know, is a enterprise transportation platform that is comprised of a whole boatload of tools, right? Here's Here's our tools page. Lots and lots of capabilities to help support transportation agencies and professionals like yourselves. Today, we're just going to focus on trip analytics and the current release, which is 3.0, which is comprised of kind of 3 tools. How it's organized today, the current release is comprised of 3 primary tools: an OD matrix tool, a segment link analysis tool, and route analysis. Again, I'm going to be focusing today on the current release. That's version 3.0, as we explore some of these video demos and capabilities, and even some of the use cases from agencies, primarily focused around a current release, that being 3.0. Before I go too much further, though, I think it's important to understand what I will be showing you from an analytics and solution perspective is being driven by waypoint-based trajectory data from our friends at INRIX. This data source, if you will, is pretty remarkable in terms of its scope and its penetration. The waypoint-based trip data from INRIX, that is just one of many that's supported out of the box with trip analytics, is comprised of about 100 million trips per day. 100 million trips per day. Nearly 2 billion vehicle miles traveled is what that represents, with super high frequency ping rates. So, all of these sources that are feeding this group of 100 million plus trips, things like local fleets, consumer mobile phones, like everywhere you walk around with location-based services enabled on your phone, that's picking up location information. Connected vehicles is a big source. You roll a car, a vehicle rolls off the assembly line today, and for the past 10 years, most of them, if not, well, now today, all of them have embedded GPS. You may not have an onboard nav system, but those vehicles all know where they are at every moment in time along the pathway that they may be driving. So connected vehicles is a big source. Local fleets, delivery vehicles, as well as long haul trucks, all the sorts of different data types that are feeding these 100 million plus trips every day, providing basic insights. It's all anonymized, but with just a coordinate value, a unique ID, and some bearings, we can associate the path of all of these different data types to a road network and provide some really, really cool analytics against that data. From a penetration rate, I've heard some recent data points that this data source represents nearly 15% of all vehicle miles traveled across the country. So you've got a tremendous and statistically significant sample of every trip that's taken across the United States. So statistically significant, the data, again, it's a sampling of all trips, but significant. One of the things we like to highlight about trip analytics, as well as in this particular case, this underlying data, is that all this output data can be downloaded for further analysis. RITIS, the platform as a whole, focuses on this notion of interoperability, being data agnostic, but also the ability to take any analytics from any of our solutions, trip analytics not being an exception, and be able to export out the results of that data. So you can explore it in your own BI tool or GIS platform of choice. This is just an example of just one of those 100 million trips that I just mentioned. This is a vehicle, maybe it's a connected car. It's got its GPS pings. Notice it's coming out of the neighborhood. These green dots, hard to see maybe on your display, but these green dots represent the GPS pings. The further apart they are, of course, the faster the vehicle's going. You can see here in this leftmost inset map, this vehicle's gotten on the freeway, as it speeds up, these blue dots are further and further apart until that vehicle gets off the highway. You can actually see turning movements here. And maybe they came to a stop because that particular unique ID paused at that signalized intersection for a while. Anyway, that might be a follow-up opportunity to talk about our signal analytics product at a later date. But you can see this vehicle navigating all the way over to the Home Depot Center because they need to pick up some materials for their home improvement project. So trip analytics is set up for a number of states. What I'm sharing with you today is deployed technology. Version 3.0 is deployed. There are a number of states that have already subscribed to trip analytics as well as data, this waypoint data from INRIX. And you can see the scope and the extent of some of this data for different regions. The dark green represents the actual state, the bounding box, and the light green represents the full extent of every trip that's taken in or out of the core geography for the period analyzed. So we're excited that this is deployed technology for a number of states, and hopefully what you see today will excite you to kind of move forward yourself if you're not using trip analytics yourself. So again, we're looking at version 3.0, this next series of video demonstrations. It will highlight each of the different tools and what some of the spatial, temporal, and vehicle type filters are that allow you to kind of explore the waypoint data that might be available from INRIX. So this first tool is the OD matrix tool. This one, sort of a standard set of OD geographies are provided to you out of the box: counties, sub-counties, transportation analysis zones, and zip codes. You could do multi-state OD analysis and or in-state analysis from an OD perspective. Provides every single possible connection between the two. Lots of really nice temporal filters from a time of day, day of week, month of the year. And if you subscribe to multiple years, the ability to filter that out as well. In here is also vehicle type filters. We'll see that later. But here, I'm kind of filtering out the O's and D's to just the top destinations. We see here that this is a zone map giving us a spider diagram. You click on a particular origin geography, it shows you all the destination geographies that are connected to that origin and all the trips. Some top 10 OD pairs, filtering out data based on maybe higher values from an OD trip perspective from that zone map. So that's the OD matrix tool. Next, I wanted to share with you the segment analysis tool. So maybe you want to do some link analysis and understand the pattern of movement, the volumes, where people are coming from and going to through a particular corridor. So in this video demo, we're looking at a corridor right through Atlanta, Georgia. This is I-75, largely comprises a good portion of an interstate through the middle of Atlanta. We're saying, hey, I want to know all the trips that ran through just that one segment. And the results come out, all the origin geographies are in orange and the destination geographies were in blue there. Here I'm going to see if I can pause this for a minute. Notice here again, we have filters for trip vehicle type, whether it's light vehicle, medium vehicle, heavy vehicle. One of the common questions that we get with regard to these trip vehicle type filters is, hey, Rick, how are you able to determine that? Well, the source for this this waypoint data is understood completely by INRIX in this particular case. They know who's feeding them this waypoint data, so they're able to generally categorize that data by lightweight vehicles, medium weight vehicles, and heavy vehicles. Medium vehicles might be a box truck, delivery truck, and so forth. So the characterization of the source helps them kind of refine and your ability to filter that data out by vehicle type. Lots of filters beyond just the traditional spatial and temporal filters for even doing link analysis. Next is the route analysis tools. So imagine you want to explore what the impact, you'll see this in some use case scenarios that I'm going to share with you later. Maybe you want to explore the impact that a detour or road closures had in terms of traffic flow, movement, volume, increased volume or decreased volume in some areas, that those particular events, road closures or work zones have had on movement of traffic. You say, all right, I know that I need to start from here and move to, or I want to analyze movement and flow of vehicles from this standardized geography to a defined geography. You can upload your own custom geography. So this particular tool in our next release, lots of flexibility for uploading customized GeoJSON files to help with defining the spatial parameters of your query. So here we're using a standardized geography and a custom geography, and the results are going to give you all the routes, every single route for the temporal period that you analyze from that geography, that standardized geography, to the new custom geography. Lots of cool screen lining tools as well. When we look at this demo here in a moment, that lets you digitize on screen a line across these paths that were taken during that period that you analyzed, to then focus your understanding of what the number of trips that were taken, the percent breakdown, and so forth. So let's take a look at how the route analysis in version 3.0 is used. So here we're setting up our origin geography, standardized geography here in Savannah. I want to say, hey, you know what? I want to know all the routes that were taken to basically the Atlanta area, kind of setting that up from an OD perspective, setting up my temporal parameters here. There's my vehicle types that I can filter out as well. Notice the results. It's giving me a big list of every single route that was used. I'm filtering down to just the 3 or more trips that were taken out of Savannah and to the Atlanta area. Notice this is that screenline tool that I was talking about. So there were several routes taken out of Savannah to the Atlanta region. Took this screenline tool here and just digitized a random line across the routes so that I could get a breakdown, a very specific breakdown of the number of trips and their percentage relative to those 2 routes in particular. So really cool capability to explore, in particular, the number of trips that were used during that temporal period that went across those routes from an origin geography to a destination geography. Moreover, notice this down here. See this little coordinates box? This gives you the ability to copy those coordinates, run this analysis again. Notice up here, you got an edit query. Maybe you want to run the analysis on a different time period, different temporal period. All right, go back, edit your query for another time period, and then you can dump those coordinates right into this box and make a direct comparison over different periods of time. So some really nice features there for exploring trips across specific routes from origin to destination. So these are largely capabilities that are currently available, have been deployed for several years now. We have, as I noted earlier, several states that are taking advantage of trip analytics and this waypoint data from INRIX. We are working hard to deploy our next release. And much of what we do, as I've indicated before, from a data architecture perspective, is keep things open. So again, we appreciate your feedback with regard to the OD and waypoint-based data sources or data vendors that you might be exploring or actually have in-house already, because that's going to really help us continue our partnership work with companies like AirSage and Geotab, INRIX, and others. As I noted earlier, WeJo, we've already done some exploratory work and integrated some WeJo data and can take advantage of that almost immediately. But some real important and exciting work in opening up trip analytics to support additional data. So more feedback, the better. In addition, we're also incorporating some additional sorts of filtering capabilities, which I'll get to in a moment. But next, a lot of you had expressed some interest in the National Household Transportation Study, this current release. This is I guess this release is largely funded and supported through a pooled fund. We'll have a lot of details to this, but a few months ago, working with Federal Highway Administration, we grabbed a sample set of NHTS 2020 data and we dumped it into trip analytics. We said, you know what? This really showcases this notion of data interoperability or open data architecture perspective for trip analytics. So let's see what we could do with this NHTS data. As you know, as you may or may not know, with NHTS, it's set up for the entire country. It's these broad regional geographies. I'm afraid I don't know the context of how these regional geographies were defined. But let's say in Virginia, which is where I'm from, there might be 12 geographies that have been dumped into NHTS, but it's a big OD grid system based on these geographies. So here's just a quick demo of what we've done with NHTS. So we're going to do a quick OD matrix. Again, we're using Georgia and Florida. I wanted to explore, what are the travel patterns between Georgia and Florida for this data set, and how are people traveling? Notice here, I'm going to try to pause again for the trip filters. It's not going to be just light trucks, medium trucks, and heavy trucks. Look what we have now. We've got air, we've got rail, we've got other, because the data supports it. We also have access to trip purpose that's been rolled into this. We also have distances of travel that we've incorporated into the trip filters for this NHTS data set. So some pretty cool additional filters that we've embedded into this exploratory sample data that we received from Federal Highway. This should be available to those states that are contributing and participating in the pooled fund within the coming weeks and maybe within the next month or so. So some pretty exciting capabilities there. That last point, download matrix as a CSV. A lot of you, I do know, particularly on the planning side, are big Esri users, leverage the ArcGIS platform. We have heard you. A number of you who are already using trip analytics have expressed to us, hey, CATT Lab, your output data, what you export or what we export out of trip analytics, we need some common unique IDs so that we can quickly marry that with our GIS data files back in our home shot. So we're working on that. particularly for the next release, which is a great segue to the next generation trip analytics. I got some feedback from our product manager, Greg Jordan, earlier this week about the additional capabilities, the additional value that Trip Analytics version 4.0 adds to the already existing capability and feature sets within 3.0. I thought, this could be a good way to kind of visualize, Trip Analytics. So our current release, which is largely what you've seen so far, you got a whole bunch of already wonderful capabilities, right? We've talked about this notion of being able to export your data easily, to explore it further in your own GIS platform or BI tool of choice. That's standard. That's out of the box with Trip Analytics 3.0 already. We're supporting waypoint data sources. You've got some cool zone map visualizations. We explored the spider diagrams that you can click on an origin geography and spider diagram out to all the destination geographies. All these wonderful capabilities in the current release, but now we're adding some absolutely groundbreaking capabilities in version 4.0. You're going to see some of that in the use case scenarios that I line up for the end of today's presentation. But in particular, we really are focusing, product management team is really focused on providing support to modeling community to help with calibrating your micro simulation models. It's really phenomenal for analyzing small geographic areas. You could drill in to a neighborhood, define your study area, and explore all the trips that move in and out of different gates, different roadways between specific geographies. Super cool stuff. And quite honestly, Trip Analytics is the first to market for most of what you're going to see with Trip Analytics and this kind of feature list that I have here. Supports bounded study areas. This is really cool new innovation that you'll see as well. You define the study area. You can set up standard geographies. You can bound your study area by the geography for the data set or the state that you're subscribing to, or you can set up your own custom geography. We'll see that in a little bit from a study area perspective. Origins and destinations for external start and endpoints will be reported at crossing points of the study area boundary line. So you set up a study area and you can actually count the number of trips that cross through the boundary at specific intersections of that boundary to the roads that are coming in and out of that boundary and study area. Really, really phenomenal, groundbreaking capabilities. Some of the filtering just kind of help you visualize what some of these spatial filters are that we're releasing in this next release. We're currently kind of rolling this out to select beta community of testers and evaluators, getting solid feedback. We want to make sure that this next release is solid and firm before we release it out to the general user community. But some of these new spatial filters provide some really, really interesting opportunities to explore different sorts of use cases, like, what's the commuter arrival times into my town, or, what time are people, let's evaluate between this period of time, what the volume is coming out of my community, and looking at things like cut-through traffic. So you could set up all of these different spatial parameters to evaluate each of these different conditions, including any combination of the above. As I've already mentioned, we're also, if the data set supports it, doesn't matter whether it's OD data or waypoint data, if the data supports it, Trip Analytics can incorporate additional vehicle types. And you saw that with the NHTS data set. In terms of trip purpose, also illustrated with an NHTS data set, and trip distance. again, if the OD or waypoint data that you provide to us has these attributes and characteristics, we can incorporate that into the next release. So at this point in time, I've been talking quite a bit. I'm going to pause for a minute. There's a lot to cover, which is why I've kept the cadence that I have. We have a lot to cover. I want to make sure we get everything in during this workshop today. But I do want to pause. My colleagues and friends, Michael Pack and Greg Jordan, have been diligently manning the Q&A dialogue between attendees and ourselves, kind of operating the workshop today. So I'd like to pause and ask Michael first. There's a couple of questions. Maybe if you can characterize a couple of questions and answers that have been asked, and some answers to share with the rest of the community. So Michael, if you could start.
I think we've been answering everything pretty thoroughly thus far, and a lot of the questions are, individual specific.
Okay.
So I don't know if there's anything we need to go over publicly right now.
Okay, great. So no broad questions that might be relevant to the rest of the community. If there are questions, now's a great time. While I'm paused.
Well, there's one.
Okay.
Someone asked, you keep using the word data agnostic, and the question was, what does that mean? And what it means is we're not married to any one data provider. So you saw Rick do a demo of INRIX data in TRIPS Analytics. There's also the National Household Transportation Survey. And then we've got WEJO data, and there's others as well. So that's what data agnostic means. We don't care what the data is. Most TRIPS data, OD data, waypoint data fits in this tool in some way, shape, or form.
Thank you, Michael. Again, while we're paused here for a moment, feel free to type in any questions that you might have independently, or if there's something that you think the broader community might be interested in better understanding, like that question about data agnostic and what that means, feel free to type that in. All right. I'm going to proceed. Hearing none. The next few slides are really designed to share with you some of the great work that our users that have already deployed trip analytics using this INRIX trip waypoint data over the course of the past several years. We've got a couple of use cases. Always like to highlight some of the good work that our user community is doing. One of the early adopters of trip analytics was Rhode Island DOT. I'll share a study and some work that they did with trip analytics. The Nashville MPO did some early analysis and has done some early analysis and exploration, but I'll also share with you a scenario later using Tennessee data. And then Georgia DOT, as Matt had mentioned, and I kind of noted as well, I was down in Atlanta with Georgia DOT, about 90 users from across the state agency, a bunch of consultants and MPOs were in attendance during a kind of a half-day training, professional development training activity that I delivered down there. And almost within a couple of days of me being down there in Atlanta, one of the attendees of that session came back with this really cool use case that I'm going to share with you. So let me just go over those real quickly. Again, one of the early adopters, Rhode Island DOT, they set out a couple of years ago to do some analysis of some truck origin and destination work for specific areas within the state. And what they realized after a bit is, while they were very focused, maybe not myopic, but pretty selective about where to start, it can be daunting, right? So if you're doing trip travel pattern sorts of analysis, particularly for freight trucks, you kind of, sometimes you have to start small, but they realize that, hey, this trip analytics solution with INRIX data, that can help us blow out our analysis to the entire state and get a comprehensive view of truck origin and destination patterns throughout the state. And then the results of that, we're going to push into the form of a heat map. So very, very, very quickly, they caught on to the value of trip analytics, running their analysis, and some of the some of the output or the results supported a better understanding of trip origin patterns and destination patterns, particularly from a freight truck perspective within the state, to help drive maybe tolling of freight trucks that pass through the state of Rhode Island. One of the interesting findings that came out of using trip analytics that they were not aware of is this hotspot right here from an origin perspective. It turned out, you know what, all of this makes sense and all of this makes sense, but we were not aware of this origin hotspot. What is that? So they investigated further. Turns out that there's a CVS distribution center right here. So the trip analytics was super useful at exploring patterns, determining, whether to gauge, how to gauge a tolling, perhaps a tolling policy within the state, but also from a data visualization perspective, they took the output from trip analytics, they brought it into their GIS platform of choice, which was Esri, and they generated these heat maps that help them tell the story to Rhode Island elected officials, as well as executives within the state DOT. In the Greater Nashville Regional Council, a friend of ours over there did a quick early look of OD or waypoint data from INRIX using trip analytics to kind of explore, again, maybe the idea of putting a focus corridor or bypass for freight trucks in the state. So they ran, this is some early analysis that they did using trip analytics, but interestingly, here again, they took the output and did some data visualizations in another platform. Point is that they couldn't perform the original analysis without trip analytics and this waypoint data. So this is that example from Georgia DOT that I thought was really fun after being there, doing some professional development training. One of the users came back and said, hey, Rick, I was doing some exploration of this. We're thinking about putting in a bypass right here and want to do some early analysis of the O's and D's through this area to determine, is there some justification for building out this bypass? This sort of data, right, can definitely help justify new projects and scenarios like this. So trip analytics was super helpful in assisting capacity analysis at those two intersections, so they can more carefully focus and assess the travel patterns through those roadways there. So a really nice example out of Georgia DOT. All right, from here, I'm gonna step into another slide deck that touches on some scenarios that were set up within states that already have or is subscribing to trip analytics and have this waypoint data that kind of comprise a couple of different use case scenarios. You saw this slide earlier where, and basically setting the stage to ask you, what are the use cases? What are the scenarios that you could really, that trip analytics and OD or waypoint data could really help you with the work that you do in your agency, whether it's from a operational perspective or planning perspective. We came up, again, Michael and Greg were super helpful in today's illustration of scenarios that we thought through that met some of these use case examples that walk you through a couple of I'm gonna, Esther, I'm gonna get back to this one later, if that's okay.
No problem.
So I'm not going to jump to that. I'm going to jump to my other slide deck. So I just by default, I click the next button. So hang tight, everyone. I am going to share my other slide deck, which has some really, really cool use cases. Again, that we developed internally, but I think are great illustration of how these tools, how these capabilities can support the work that you do. All right, Esther, I'm going to do a check here in a moment. Do you see use case scenario number 1?
Yes, we do. Thank you, Rick.
Fabulous. Thank you, Esther. Well, I am kind of in transition, so maybe now's another great time to ask, see if there's any new questions. Greg, that might be relevant to the broader community to share the answers back to everyone. Or Michael, any questions? Hearing none, I'm going to proceed. All right, so this first use case scenario, I'm calling them scenarios because, again, they are real, but we fabricated we fabricated what a state agency like Tennessee DOT might do as a result of an incident like this. So this is a real world scenario. This is this bridge crack, this bridge that is on I-40 that crosses from Tennessee over to Arkansas. It cracked. I mean, that is a heck of a crack. Not sure how that got there, but anyway, I'm certain that some material or mechanical engineer can help me understand that, but that is a serious issue. So anyway, the crack was identified. Thankfully, Tennessee DOT shut the bridge down, and then it then had to get repaired. So the impact was could have been, and well, likely was substantial. So with trip analytics, even the current release 3.0, Tennessee already being a user of both the trips data and trip analytics, you go in and assess the trips across the bridge into the state, out of the state, what the impacts were within the immediate vicinity of the bridge, as well as, what happened in West Memphis over in Arkansas, and then what was the impact on trips that were heading into Shelby County, which is the county that Memphis is in. I think that was right. Is that Shelby County? I think it was Shelby County. So first, identifying the problems, clear, the bridge is closed. We want to understand the impact of, closing that bridge to other key corridors. And other key corridors are, this is the corridor that's getting shut down at that bridge. And let's assess what that impact might be on I-55 and trips and travel across that area. And then we'll kind of move out and explore additional impacts away from the immediate area. So the first set of evaluation was sort of examining bridge specific impacts. So what happened, let's assess at the time of the incident, and post closing of the bridge, what the volumes were, what the trip counts look like. I've got to don my readers as we explore this. So this is a snapshot of some route analysis. Notice I'm using out of trip analytics, using the route analysis tool. All these scenarios largely use route analysis tool. We're using the route analysis tool to say, hey, starting in Shelby County, which is identified here. Again, this real data, not mocked up. We ran this analysis. Shelby County, Monday through Friday, 5 a.m. to 10 a.m. I'm looking at heavy trucks. Pre-incident, we've got a pretty good number of trips, freight trips that cross over I-40 across the bridge that had the crack. 33% of all trips versus the remainder of the trips. Were using I-55. That was in April. Now, the month of the incident, we already see that some of that trip pattern was starting to decrease across I-40 for heavy trucks. But then, after the bridge was closed, very cool, very clear pattern that, hey, there's no trips on I-40 any longer. They have all moved, all the truck, medium truck, and heavy truck patterns and movement out of Memphis have gone over, are now going across I-55. So really, really clear pattern. Then during the repair, we see the continued pattern of I-55 being used. Now then, as the bridge opens again, we start to see clear evidence using this statistically significant sample data. Don't think of these numbers as all numbers. Remember, this is a sampling, but a sampling of all trips, 15% of every trip across the US that's taken every day. So it's statistically significant data. We start to see I-40 getting more traffic, and then in September, kind of back to its normal trend for medium heavyweight vehicles. So then we wanted to explore what that looked like. What was the impact in Arkansas, in West Memphis area? So we crossed the river and we used that screenline tool again out of the route analysis tool. We digitized this screenline tool across some key corridors away from the immediate area of the closed bridge to kind of identify what the trip patterns look like. So here we've got a distribution, the number of trips, the percent breakdown. In April and May, pretty standard patterns. But what we saw later is that for some of these routes, like US 70 and this, I think it's South Loop. Yeah, this is called the South Loop. They really began to pick up additional volume or additional trips from freight trucks. But then as you see, as we move, was able to copy those coordinates over and evaluate different time periods. So it's the same screen line, but I'm just looking at different dates. I was able to look at every single month. Let me go back so you can see that. April, May, June, July, August, and September. So some clear patterns emerged while that bridge was closed. US 70 and this South Loop Road picked up some of that heavy freight truck activity, and also, as you'll see in a minute, some of the lightweight vehicles. So some observations. I did some quick analysis during the bridge closure and repair. US 70 South Loop received additional freight activity, and post-bridge reopening, those arterials that were impacted, they kind of returned to normal. Could not assess that sort of impact without trip analytics. So now I want to take a look at the same scenario, that bridge closure, same scenario, but let's look at incoming trips into the region. So I backed way out and said, hey, I want to understand all the trips that might be coming in from Arkansas into Memphis, Tennessee. So again, use the Screenline tool and Trip Analytics. digitized myself a couple, just, pretty standard line across a couple of key corridors so that I could look at, this is passenger vehicle, or no, this is still medium weight and heavyweight vehicles, but just wanted to look at the patterns of movement from April, May, and July, June and July, August and September. Clear patterns emerged that, again, moving into Shelby County and the Memphis area, there was a pickup, specific routes that were added, or not added, specific routes that were leveraged to avoid having to use I-40 and that particular bridge, kind of move around the issue. So my assessment was, this is all early in analytics, right? Just using trip analytics and this waypoint data, so that the regional impact coming into Shelby County, I-40 trips into the county were reduced anywhere from 5% to 25%. So pretty significant reduction in trips on that particular corridor. But then other roads like I-55 and US 61, they picked up quite a few additional number of trips. And interestingly, it kind of continued for several months after the bridge was reopened. Very, very clear patterns that arose by doing this analysis. All right, so I'm going to step into use case scenario number 2, but before I do so, Michael, are there any questions that might be relevant to share, questions and answers might be relevant to share with everyone?
Sorry, I was actually talking earlier and my line was muted. One of our friends up at Rhode Island was talking about, as Josh O'Neill was talking about some of the prior things you were showing. Is happy to see some of their maps again. They actually conducted a follow-on truck study of their port in Providence that confirmed the OD data that they were seeing in these tools. That was good. And then Josh made another comment later. He said that the data can be used to help identify areas for potential freight priority projects that could be included in a state freight plan update. They haven't necessarily done that in Rhode Island yet, but they can see where the data could play a useful role in helping to shape priority project selection. It's not related to the use case you just showed, but wanted to point it out. And
thank you, Josh, for sharing that. It's good to have you on. Hope I represented your good work appropriately.
And Greg, I don't know if there's anything else you've been working on.
I think we got it going. We're good.
Okay, cool. Well, let me carry on. Hey, Esther, I'm going to do a time check. How are we doing?
It's 11:18. You have about 40 minutes left.
Fabulous. Thank you very much. All right, we got a couple of more use cases, and then we'll start wrapping up. We've got additional polling questions we'd like to ask, but 2 more use cases to share, and then we'll move on to the next segment of today's workshop. So this next use case scenario takes us into our partner state, North Carolina, who's been subscribing to trip analytics for and waypoint data from INRIX for some time now. This is also an interesting study to show the impact that detours may or may not have as a result of a big bridge replacement. So this particular scenario, there was a bridge replacement here in this Cold Springs Creek, which is just outside northwest of Asheville, North Carolina, going across, runs parallel to Pigeon River. Super old bridge, had to get replaced. And so the state DOT put out this public notice that, and press release, hey, we're going to be replacing this, and you're being warned that things can be a little jacked up as a result of this bridge replacement. And we're going to implement some zippering at the bridge, because we're going to do one side of it at a time, I suppose. But if you want to, if you're going from Knoxville to Asheville or vice versa, we recommend a alternative route. It's a detour to, that was recommended by the state DOT. So they published this, pushed out this press release to the traveling public that, hey, warning, we're going to replace this bridge and its primary corridor between Knoxville and Asheville. So consider this alternate route. So the bridge replacement kind of took place between November and May, November 21 to coming up this year. So what we did is we took trip analytics and waypoint data from NRIX. We said, hey, you know what? We want to analyze two primary facets of this public notice and press release. For the suggested detour around I-40 and where they're replacing the bridge, is the observed additional travel time consistent with what was reported in the press release? And then also, how effective were the suggested detours or alternate routes relative to both passenger vehicle and truck trips? And then were other routes being used as well? If so, how is it impacting those routes? So the state DOT may recommend a route around I-40, but maybe there were some other routes that were impacted as well. Trip analytics helped to tell the story and answer those questions. So this is an example of some analysis in and around the time that the work began for that bridge replacement there on I-40. Kind of cool way to leverage PDA to show that, yeah, we've got multiple dates here. We've got the 13th of November, 14th of November, 15th, and 16th. You know, apparently this is southbound traffic on this particular day. It's when they got started with doing the work zone data. So it clearly shows that we've got some serious congestion, speed issues where they're doing the work. Now, I'm going to set the query up with a quick video demo, and then we're going to walk through the analysis and kind of explore the route analysis that was done using trip analytics and waypoint data from NRIX. So thank you, Michael, for setting this up. We're going to go ahead and define through our Tennessee data. Notice we got a broad list of states that are already enabled with trip analytics and all this cool data from various different sources, primarily NRIX. Here we see that there's our core geography and the extent, the geographic extent of all trips in and out of the state for the temporal period that the state has subscribed to. I'm going to go in and set up our analysis. Set up our origin geographies. Knoxville, Tennessee area. I think I was saying North Carolina earlier. I'm sorry. We're working in Tennessee. Set up the destination geography, which is the county around Asheville. Establish our temporal parameters, lots of filters again to decide, okay, I want only these particular days of the week, or only I want the weekends, and oh, okay, I want just this particular month, and oh, time of day, I want only the morning trips, or only trips from 5 a.m. or 4 a.m. until midnight. And then some additional parameters for the condition, in and out, through, started, ended, whatever. Submit that query, up pops the results. And the table at the top, again, represents every trip during that temporal period that we ran the analysis. I'm going to filter out only the routes that were used, where there were 2 or more trips. That's what that previous dialogue was for. So now we're seeing all routes that were used that had 2 or more trips between Knoxville and Asheville. Now I'm setting up my screen line now. Notice the screen line tool here. I'm digitizing a line across these primary roadways, because what I want to do is explore specifically how many trips and percentage relative to those 3 roads. What was the percentage of trips taken for each of these respective roads? For this is I-40, okay? This is another route that was taken, and this is yet another route that was taken. Just quick note, this was the recommended route that that stated recommended around that bridge replacement. Oh, it is North Carolina because that's where the repair was done. Anyway, so as we drop into, oh man, sorry. Where do we leave off? Continue the video demo. As we drop into exploring the routes that were taken between those 2 geographies and digitizing that screen line, we get that pop-up here in a moment again. Sorry. We get a pop-up that tells us explicitly what those trips were. Now then we can take that same set of coordinates. Now, right now we're running our analysis on October. That's before the repair began. We take those same screen line coordinates, run the analysis for November, and then run the analysis for December, and then January, crossing that same path. And that's what the next set of slides will show us as we explore the impact of the bridge repair or replacement on trips through this general vicinity. So we finished, notice that screen line. We can move it, modify it, and then ask for the results. And it gives us a breakdown of the number of trips through each one of those corridors. All right. So let's look at the analysis. So I'm going to walk through a series of slides that help us better understand the impact and answer some of those questions about, hey, was the travel time that we suggested through that press release, was that fairly accurate? And if so, helps us calibrate things. But also, are travelers using the recommended detour? So first set of slides, we're going to be looking at trucks, medium and heavyweight vehicles, and you'll see up at the top how we're breaking it down month by month for the corridors or routes that were taken between Knoxville and Asheville. So notice in October, when we draw our screen line using those coordinates, we draw that screen line. Guess what? Everybody's using I-40. But as we move into already November, we can begin to see that there's already a pattern of trips that are starting to utilize that recommended route. And then if we look at travel times, we know that pretty consistent travel time taking I-40. But then looking at the travel time for the suggested route, guess what? It's pretty accurate. The detour is verified. It's taking about 45 minutes longer than I-40, even with the zippering that's going on at the bridge repair. So very clear, very specific, data-driven results to help us tell the story, validate travel time as part of that, as part of the information campaign out to the general public and travelers. Now, if we look at light vehicles get a little bit different perspective because, hey, you know what, medium and heavyweight trucks, they may not be into taking this particular route because it's windy, curvy road. But as we look at the conditions for lightweight vehicles, we had before the replacement began, you know, again, a majority of the light vehicles were taking that path. But as soon as the project began, we saw an okay number of trips that were starting to use alternative routes. But here's what's interesting, I thought, is that not only were passenger vehicles taking the recommended route, but guess what? They were taking some other routes as well. And hey, you know what? Maybe this is a prettier drive. I'm going to go this way. And that's what happened. You know what? I am on annotate mode. That's fine. I'll keep it as a laser pointer. Now, here's where we begin to characterize how effective, you know, the detour plan was, or the recommended detour was. As I move through these slides, you'll see that each of the primary corridors is going to be highlighted in blue, and that corresponds to that route and all the roads that make up that route in the table above. So here we, you know, early on, we could see that there were alternate routes besides the recommended detour that were actually used by lightweight vehicles. In summary, kind of cool analysis that we're able to confirm that not only is the travel time on par with what we expected, but we're able to observe that, you know, there's a clear decrease in the number of trips that used I-40 during that period of when the repair replacement began and subsequent to that. And then those alternate routes, or the alternate detour route that was recommended, in addition to those other routes that you saw here and here, they increased, the number of vehicles and trips increased by 2% for the month of November. So great, clear patterns, insights, data-driven insights to vehicle counts. All right, I'm going to pause, kind of set the stage. This is my teaser use case scenario. It's a teaser because my friend Greg Jordan, who's on the line, used our next release, which is in beta right now. Again, we've got a few select people from agencies like yourselves that are exploring this next release and all of its groundbreaking capabilities so that you can, if you're a user of trip analytics or you wish to be a user of trip analytics and some of this waypoint data, you can perform similar analysis yourself in support of your agency. So a quick shout out to Greg for setting this up. This is this scenario is kind of interesting because it's you know, in my back door, basically, or in my backyard, not my back door, but my backyard. A few years ago, there was well, within the last couple of years, a small ferry that was essentially shut down, and there's a land dispute for the owner. There's a land dispute for the land that supported this ferry that moved passenger vehicles largely from just outside of Leesburg, Virginia, across the Potomac River into this portion of Maryland. So pretty critical. The highly used ferry, it was shut down, so it impacted. It certainly impacted the movement of passenger vehicles by and between Northern Virginia and Maryland, because the alternate routes across the Potomac River, there really isn't any. There's a bridge here at 15 and a couple of others up by Harper's Ferry. And then the closest one downriver from White's Ferry was the American Legion Bridge, which is 495 that takes you into a mess of congestion. So some analysis, so understanding this kind of prompts the question is, hey, would it be useful to have another bridge that crosses the Potomac River in and around this part of Northern Virginia relative to Maryland to help with commuter traffic? Or do we let's get this land dispute resolved and get White's Ferry going again because it's super popular. So a scenario like this, we can use some of these innovative, groundbreaking capabilities within Trip Analytics version 4.0 to help us answer and assess that value. And so Greg's phenomenal, right? He puts this scenario together. He said, well, how would a modeler think about this? The modeler would say, well, I've got all of these study areas that are, population centers in Northern Virginia. You've got Charlestown, Percival, and Leesburg, Sterling, Reston, all of these population centers that are that could largely use a ferry or bridge crossing between the two states across the Potomac, and it's matching population centers on the Maryland side. So these are kind of the identified kind of bounding boxes for those population areas that could leverage this. But I also have to identify where the crossings are. So these are road segments that exist now or could exist, potential road segments that could exist. And then notice that all of these purple arrows, this represents gates or points of entry in and out of via existing road segments to my study area. The study area is this broader area that's defined in the kind of the medium gray line. It's polygon. There's two of them. There's one for Maryland, and then it's divided right down the Potomac River, and then the study area that's in Virginia. Now, in 4.0, you have the ability to create all of these custom focused geographies and custom study areas so you can refine your understanding of these travel patterns very specifically. And you'll see what I mean here momentarily. So Greg goes out, he takes his, creates these GeoJSON files, and each one of these GeoJSON files is helping us set up and establish the study and assess flow, movement, trips in and out of all of these different geographies and road segments. So you have, the population areas, you have the segments themselves that have been incorporated into this study that he's defined by himself, the study area, right? Remember I said there's a study area in Virginia, and then there's a study area in Maryland, and then all the urban areas in Virginia, so on and so forth. So all of that's been custom configured, defined by Greg to then set up a study and run some analysis in version 4.0. So you are amongst a very few, I guess there's maybe not a very few of you, there's 140 of you that are on the line right now. You get a sneak peek of version 4.0. So here we are, we've got a couple of options for setting up a study area. In version 4.0, that everything starts or begins with establishing a study area. There's a couple of different options for that. You can focus your study area on just the bounding area for the subscribed data that you have access to. Typically, that's a state-based geography, but we've got some users down in Southeast Florida. They set it up based on metropolitan study area, or your study area can be the full extent of all trips, Or in Greg's case, he set it up so that it's a defined study area. And he created 2 study areas. Again, the Maryland study area to the east of the Potomac River and the Virginia study area to the west. So he set those up. And then he says, you know what, for this first query, I want to understand trips from Maryland into Virginia during the weekdays from 6:30 a.m. to 9:30. And I want to do that assessment for all vehicle types, set that, set those parameters and filters. And here's some of the results. There's 3 primary data visualizations or outputs in version 4.0. And it's similar to what you've seen in my earlier demonstrations. And that is, you can visualize these results in the form of an OD matrix. You can visualize the results in the form of a zone map, where you can see those spider diagrams linking origins to destinations, and or route maps or route analysis maps. So a couple of different data visualizations, and we'll see examples of those in the results of this study that's analyzing whether a new bridge or a new ferry would be useful between Virginia and Maryland. So just a quick assessment, we found that there's 10,700 trips during that temporal period that Greg had analyzed from Maryland to Virginia. Now then, from a report perspective, okay, we were looking at the OD matrix, but now let's explore the origins and destinations. Let's look at these. These are, looks like maybe subgeographies or transportation analysis zones. The orange geographies and orange connectors here, or gates, represent the orange origin, and the blue geographies and blue gate points represents the destinations. So how cool is this? Rick, are you telling me that you can point at a road that crossed my study area and tell me how many trips started there and went to other locations in Virginia? Yes, I am. Check this out. So I've now labeled every origin and every destination, geography and gate point, or point at which my study area intersects a road, with the number of trips. Out of that 10,700 trips, I've now labeled every single one of those geographies and gate points. Holy smokes. Well, what if I want to explore a specific gate, origin gate? Well, here first we filtered out, we're hiding some of the lower count trip geographies. So I filtered those out, done that right here, said, hey, you know what? I want to hide the lowest color range. So if it's, I just want to see 10 or more trips. So that's all you're seeing. It's just 10 or more trips, as compared to, you'd see all trips here. So now I filter that out, but now I want to explore at that particular crossing, that road that intersects my study area. I want to know every destination geography that the trips went to. And that's what the spider diagram shows. It's showing me every destination geography for that temporal period, for this study area, for every gate, and for every geography that the trips went to at that one gate. And now I've moved to another gate. Wow, there's 352 trips that started, that came into that gate and then ended up at all of these other destination geographies. Cool spider diagram, very clear picture of what's happening at that particular gate. And here again, another gate exploration, spider diagram showing. And now we're looking at origin geographies. So tell me from this origin geography, whether it's a sub-county or transportation analysis zone, I'm not sure what it is, but from this particular geography, tell me, show me, count up, show me the count, but also show me what destination geographies did those trips go to. during that temporal period of time. So we're getting this combination of insights that, again, is super groundbreaking to be able to do this sort of analysis and validate some assumptions about the need for a bridge or a ferry. Could say, hey, yep, there's a lot of 49 trips that started in this geography and ended up in all of these other geographies, as well as, notice, we're also showing you the gates that they went through and giving you trip counts for those gates as well. Just remarkable insights. So that's the zone map, kind of the spider diagram visualization of the results. Now let's take a look at the route map results. We're still working with this 10,736 trips for the analysis. We're looking at, we want to start by looking at the from and to routes. So let's do that. Here, this result is showing us every route that started in this defined study area in Maryland to anywhere within our destination geography in Virginia. Again, 10,736 trips. We're going to filter out the routes so that it's just 2 or more trips. And now we can explore, we're clicking on specific bridges. When we click on those bridges and the route, you could see where all the routes are and the number of trips for that specific bridge. So this is, I think this is the one at 15, or maybe that's Harper's Ferry. I think this one's 15.
That's
Anyway,
Harper's Ferry, yeah.
That is Harper's Ferry. Thank you, Greg. So now as we click through or move through each of the bridges, we can get very specific counts of the number of trips that are moving over that bridge. We click on the bridge that crosses at 15. We get those counts. Oh, wait. Yes. Oh, shoot. Sorry. I'm not advancing. That's 15. Getting those counts. So we're exploring. Okay. So between these two geographies within the confined study area, what are the trip counts that were used? And now we're looking at the American Legion Bridge down here that's on 495, the primary crossing from in between Northern Virginia and Southern Maryland, and its routes and the breakdown of routes, or the breakdown of the number of trips across that particular bridge. So pretty exciting stuff, really compelling data visualizations and capabilities that are to come and should be available within the coming weeks in version 4.0 of Trip Analytics. Again, thank you, Greg, for sharing that with myself so that I could share that with the rest of the community. So with that, I wanted to pause as I'm transitioning to the wrap-up slides. We got about 10 minutes left. I'm going to pause and see if there are, Michael, relevant Q&A that might be of interest to the broader community. Would that be a no?
Oh, so I mean, there's lots of discussion going on the side about the very nature of how to conduct some of these studies and surveys, and they admittedly require a bit of an art, right? Back to the Memphis study, we did a fairly local analysis there to look at trips that diverted relatively close to the Memphis area. It's entirely possible that some trips some people did a massive detour and went way, way, way around, or skipped Tennessee entirely. Who knows? So you could and should expand your search area to think about those types of detours and trips, which we didn't do here because we were looking at hyperlocal stuff and the freight. I think Memphis is a FedEx hub, so we're interested in vehicles that were specifically going into Memphis. Keith is asking a question about how long it took to do some of this analysis. So the queries themselves, like setting up the query, drawing the lines and the input, you saw the video, it takes a few minutes after you've thought about what it is you really want to ask. Figuring out how to ask the question is I think the hardest part. Now, the results, it totally depends on the date range and other query parameters. If you're looking at a day or a week's worth of data, that's going to be a faster query than if you're looking at 3 years worth of data and millions and millions of trips. So some of the longer queries can take a few hours to complete. So you're gonna hit submit, you're gonna go off and get lunch and come back and get your results later, and in most cases.
Thank you for that. Good observations, and happy to hear that there's some good exchange and dialogue going on in the Q&A. So on that note, I'm going to ping everybody for a couple more questions, polling questions, just 3 more polling questions. We'll wrap up with any last minute questions. So polling question to you, the attendees. Would you consider sharing let's say for instance, you've been a user of Trip Analytics for a while, or maybe after today, you go, man, Rick, you've shown us some compelling capabilities. We're going to run out and get Trip Analytics. If you decide to deploy it, like our friend Josh up in Rhode Island, who was super kind early on to share his use case and his story with us, would you be interested in doing the same? We'd like to follow up with you. Your response is helpful. Again, we will follow up and would love to showcase you either one in our during our quarterly user group meeting, and or maybe you get showcased in RITIS report, which is our quarterly newsletter, or maybe we can integrate you into some forthcoming workshops, technical workshops like this. So would love to hear from you. All right, Esther, you see the polling question there. Answer yes or no or not sure. We could reach out independently if you are interested in sharing your use case for an upcoming user group meeting. Our results, Esther.
All right, we're going to close the poll in 3, 2, 1.
All right, cool. We got 12 of you that are interested, maybe 7 more. Thank you very much, Esther. Thanks for that. And so some of you may have been on last week's, participated in last week's workshop, was focused on integrating and leveraging RITIS report templates that help take output analytics from probe data analytics to generate these beautiful, concise, one-page reports that you could share with others, management, executives, elected officials, and so forth. One of the things that came out of that workshop, why I'm mentioning that, is that there's some clear interest by the community like yourselves in the CATT Lab partnering with the Eastern Transportation Coalition and delivering more of these. So this question is to you. We are considering developing additional RITIS platform training sessions that we deliver in this sort of format. They'd likely be 1-hour sessions. This one's a little long today, but they'd likely be 1-hour sessions. So if so, this could be a multiple choice. I'm not sure if it is. Did we set this one up as a multiple choice? Esther?
Yes, it is multiple choice.
Okay. So this helps us prioritize what we might do. If you're interested, let us know. The options are more detailed trip analytics scenarios. A quick note on that. Once Trip Analytics 4.0 is released, our intention is absolutely to do a follow-up. My colleague Greg, who's our product manager for Trip Analytics, he'll give us a nice overview and additional demos of 4.0. You saw the teaser today, but there is more to come. We promise we'll plan and organize that for you. But other options would maybe be a session on signal performance measures analytics, maybe real-time incident detection and management capabilities. And if there's something else you'd like to see us present on in a technical framework like this, just note it in the Q&A box, Q8, and make that note. So we'll wait a few moments for our responses. And Esther, I'll turn it over to you to close it.
All right, we're going to close the poll in 3, 2, 1.
Outstanding. Great feedback. Thank you, everyone. And we will explore each of those and kind of prioritize forthcoming technical workshops like this. Our last polling question for you, again, thrilled that you're contributing and providing feedback. We hope these sessions are useful, and we'd like your feedback. Is this useful? Give us a score. 1, little value. Rick, you suck. I don't want to listen to you ever again. 2, yeah, this was awesome. 5, extremely valuable, or somewhere in between. Love your feedback. We would love to do more of this if in fact you find this valuable. So let us know. Turn it over to you, Esther, to close. Excellent, excellent. Well, thank you very much. Great to see that you're finding some value in this session and potentially other sessions that we deliver. With that, kind of wrap things up with any last minute questions and answers from our fearless leader, Michael Pack, and our product manager, Greg Jordan, who's feverishly answering questions in the background. Any other questions and or answers, Michael and or Greg, that might be relevant to the broader attendee community?
Nothing for me.
Rick, this is Denise. I just want to thank you for spending the time. This was really well done. Hopefully helpful to those on the call. Thank you very much for taking the time to do this.
Thank you, Denise. We are happy to do it. And thank you for your partnership and facilitating this. It's awesome. Love it. Love our partnership. All right, seeing none. We will, as usual with any Eastern Transportation Coalition seminar, workshop like this, user group meetings, we will post the recording as well as the slide deck that I've shared with you today on the Eastern Transportation Coalition's website. This is kind of a last minute ask, Esther. Is there any way to share that URL with the community in the Q&A? I guess it would be in the Q&A box.
Once the slides and the recording are ready to distribute, we will make sure that everyone gets a link to the appropriate page.
Oh, okay. Yeah, I guess that makes sense. Yeah, you registered, you attended, you're going to get the link. So you'll have all of these resources. Here's some contact information for myself and others within the CATT Lab, as well as the Eastern Transportation Coalition. Again, thank you all very much. And I see that we are remarkably on time. So I appreciate you. And so long.